What if I told you that you could add Google Sign-in to your Godot game with automatic token refresh that works on Windows, Mac, and Linux? Today, you're going to learn exactly how to implement OAuth in desktop games. Let's dive in. Here's a quick demo of what we'll be building today. When the user clicks the Sign in with Google button, their browser will open the Google sign-in page. After signing in, they'll see an Authentication successful screen, all handled directly by our Godot app. Once signed in, the app will instantly fetch and display the user's information. You'll find all the chapters and timestamps in the description. And if you enjoyed the video, don't forget to subscribe. First, let's set up Google. Head over to console.cloud.google.com and create a new project. I'll name mine Godot Google Sign-in. Next, go to APIs and Services. OAuth consent screen. Enter your app name. This is what users will see. Choose Web Application from the list and hit Create. A pop-up will appear showing your client ID and client secret. Keep this open because we'll need them for the Supabase setup. In a new tab, open your Supabase dashboard. Create a new project. I'm naming mine Godot Google Auth. Set a database password, then choose a region. I'll stick with Southeast Asia, Singapore, for this demo. Once the project is created, go to Authentication, sign in providers, then scroll down and select Google. From your Google Cloud console, copy the client ID and client secret and paste them into the fields in Supabase. Next, copy the callback URL from Supabase. Back in Google Cloud Console, open the new client you just created and add that URL under Authorized Redirect URIs. In Supabase, go to URL configurations and add 4 redirect URLs: localhost 5 4321, localhost 5 4322, localhost 9999, and localhost 8080. We're adding all 4, so we have fallback options in case one isn't available. And with that, our Supabase and Google Cloud Console setup is complete. Now that Google Cloud and Supabase are set up, let's jump into Godot. First, we'll create a new script called SupabaseAuth.gd. At the top, we'll add 2 signals: auth success for when login works, and auth error for when something goes wrong. Then, we'll define our Supabase variables, including the URL and a non-key. And set up our PKCE configuration. This is what makes our OAuth flow secure. Next, let's add the sign-in with Google function. This kicks off the entire login flow. It generates the PKCE parameters for secure authentication, starts a small local server to listen for Google's callback, then builds the Google plus Supabase auth URL and opens it in the browser. The generate PKCE params function is where we make the 2 key values for the PKCE flow: the code verifier and the code challenge. The code verifier is just a long random string, We generate it using letters and numbers. Then, we hash it with SHA-256 and base64 encode the result to create the code challenge. This challenge is what we send to Google during the login request, and later we prove our identity by sending the original verifier back when exchanging the code for tokens. This ensures the login request can't be hijacked.
Before we finish PKCE generation, let's look at generate random string function. This is a small helper that takes a length and returns a random string made of uppercase letters, lowercase letters, and numbers. We'll use it to create our code verifier, which needs to be unpredictable for security. Next, we have start local server. This spins up a tiny TCP server on localhost, usually port 54321. If that port's already in use, it will automatically try a few fallback ports we added earlier. This local server is important because after Google sign-in, the browser will redirect the user back to this server with the authorization code. That's how our Godot app gets the login results directly. Now let's look at build auth URL. This function creates the full Supabase authorization link with Google as the provider. It includes a redirect URL, the PKCE code challenge, and other parameters needed for the flow. When you open this link in the browser, it starts the Google sign-in process. Next is process. This runs every frame while our server is active. It checks if a browser connection has come in, meaning Google has redirected back to us. And if so, it grabs that connection so we can handle the callback. Finally, handle callback deals with the incoming connection from the browser. It reads the data, checks if we received an error or an authorization code, and then either sends a success page back to the browser or an error page. If we do have a code, we pass it along to be exchanged for tokens. Process callback request runs immediately after our app detects a browser connection from Google. First, it reads the incoming HTTP request and gets the very first line, which usually contains the request type and the URL. From that, it finds the question mark and grabs everything after it. This is our query string. The query string is then sent to another helper function that splits it into individual key value pairs, so we can easily check for parameters like error or code. If there's an error parameter, we tell the browser that authentication failed, send back an error page with a message, emit our auth error signal, and stop the server. If there's a code parameter, meaning the signing was successful, we send the browser a success page, then pass that code to another function that will trade it for access and refresh tokens from Supabase. If neither error nor code is found, we send an error page saying no code was received, emit the auth error signal, and stop the server. This function also makes use of helper functions to parse query parameters, send the HTML response back to the browser, and handle cleanup so the local server isn't left running. Send callback response. It talks back to the browser after we've processed the redirect. If authentication was successful, it prepares a simple HTML page saying authentication successful. If there was an error, it instead prepares a page saying authentication failed and can include the error message. This HTML is then packaged inside a proper HTTP response with headers like content type and content length, so the browser knows how to display it. Finally, it sends that data through the TCP connection and closes the connection, so the browser shows the result instantly. After we get the authorization code, we call exchange code for session. This sends a POST request to the Supabase token endpoint with two things: the auth code we just received and the original PKCE verifier. We also include the anon key in the headers, so Supabase knows which project we are talking to. When Supabase replies, the request completed handler takes over. It reads the JSON, pulls out the access token, the refresh token, how long the token lasts, and the user object. If everything looks good, we emit the auth success signal and save the session to disk, so the app remembers you next time. If there is any error, we emit the auth error signal and show the error message. Store session takes the tokens and user info we just received and writes them to a small file so the app can remember you next time it launches. First, it adds a timestamp called stored at. That lets us later check how old the session is. Then it saves the whole thing as JSON into a file under the user data folder named auth.sessions.dat. Quick note for viewers. This is a simple demo approach. For production, use a more secure storage method on the OS, but this keeps the example easy to follow. Load session is what we use to read back the saved login data. It opens the auth.session.dat file, reads the text, and passes it from JSON into a dictionary. Then it checks if the session has a stored at time and an expires in value. If it does, it calculates how long it's been since the session was saved. If that time is greater than the token's lifetime minus 5 minutes, it marks the session as expired. Even if expired, we still return the data so we can try using the refresh token. If no file is found or parsing fails, it simply returns an empty dictionary. Now we add the remaining functions. Is session valid? Checks if the saved session has a valid access token and isn't expired. If not, we know the user needs to sign in again or refresh. Refresh token sends the stored refresh token to Supabase to get a new access token, so the user stays signed in without logging in again. Sign out calls the Supabase logout endpoint, then deletes the saved session file, so the next time the app runs, the user will have to sign in again. Finally, at the very top of the script, we have the ready function. This runs as soon as the node is added to the scene tree. Inside, we create a new HTTP request node, add it as a child so it can send web requests, and connect its completed signal to our request handler. This way, anytime we send a request to Supabase, we'll automatically handle the response. And with that, our SupabaseAuth script is complete. This one file handles the full Google sign-in process inside Godot. From opening the login page, catching the callback, and exchanging codes for tokens, to storing sessions, refreshing them, and signing out. Now I'll create a simple GUI for our demo app. I've sped up this part of the video since it's just basic UI setup, nothing complicated, and we'll focus more on the logic that connects it to our authentication system. Alright, the UI is ready. I've already attached a script to the root node and connected the sign in and sign out button pressed signals to that script. So we can now hook them up to our authentication logic. We'll start with the onReady variables at the top. These grab references to all the important UI elements in our scene: the email and user ID labels, the sign in and sign out buttons, and the two panels we'll switch between, the login panel and the signed in panel. Using onReady means we can access these nodes immediately once the scene is loaded, without needing to manually find them later. Now we'll add our SupabaseAuth script as an auto-load in Godot's project settings. This makes it a singleton, so we can call its functions and access its signals from anywhere in the project without having to manually pass references around. It keeps our authentication logic global and easy to use. Now I'll add the check existing session function. This function looks for a saved session using SupabaseAuth. If it finds an access token, it checks whether the token has expired. If it has and there's a refresh token available, it will try to refresh the session automatically. If there is no refresh token or the session is completely invalid, it shows a login UI. If the session is still valid, it immediately shows the authenticated UI, so the user doesn't have to log in again. The isTokenExpire function checks whether the saved session token is still valid. It looks at the token's lifetime from the session data, then compares it to the file's last modified time. If the difference is greater than the expiry time minus a 5-minute buffer, it considers the token expired. This buffer ensures we refresh the token before it actually runs out, preventing sudden logouts. Show login UI is called when the user is not signed in. It makes the login panel visible, enables the sign in button, and sets its text back to sign in with Google. At the same time, it hides the signed in panel, so no old user information is shown. Show authenticated UI is called when the user has successfully signed in. It hides the login panel and disables the sign in button, then shows the signed in panel with the user's email and user ID filled in from the session data. It also makes sure the sign out button is visible and ready to be clicked. Now we'll add functionality to the sign in and sign out button pressed functions. When the sign in button is clicked, we disable it, change its text to opening browser for authentication, and call the SupabaseAuth sign in with Google function to start the login flow. When the sign out button is clicked, we call the SupabaseAuth sign out function to clear the session, then show the login UI again so the user can log back in if they want. Now, in the ready function, we connect the auth success and auth error signals from SupabaseAuth to our local functions. When auth success is triggered, we show the authenticated UI with the user's details. When auth error is triggered, we show the login UI so the user can try again. This setup means our UI updates automatically based on the authentication state, without needing to manually check every step of the login process. At the end of the ready function, we call check existing session. This makes sure that as soon as the app starts, we either lock the user in automatically if their session is still valid, or show the login UI if they need to sign in again. And that's it. We've gone from setting up Google Cloud and Supabase to building the SupabaseAuth script, and finally connecting it all to a simple Godot UI. You now have a complete Google sign-in system running locally with session storage, token refresh, and logout all handled inside Godot. If you found this helpful, don't forget to subscribe so you don't miss future tutorials. And if you'd like to dig into the full source code, All the project files are available on my Patreon. Thanks for watching, and I'll see you in the next video.